In this video, we're going to learn about applications of trigonometry. So as the first application, we're going to talk about solving triangles. Solving triangles means finding the unknown sides or length, sides or angles. So if there's a triangle which has some unknown sides or angles, we're going to find them. So that's what we normally call the solving a triangle. So there are three types of triangles. The first one is a triangle which has all the angles less than 90 degree. So an angle which is less than 90 degree is called an acute angle. So that means if all the angles are acute angles, that means angles are 90, less than 90 degree, we call the triangle acute triangle. And then the next type is we have one angle which is 90 degree, so we call that as a right triangle. And you know that there cannot be two angle which is 90 degree because the sum of the three angles has to be 180. So if there are two, then the other angle should be 0 degree, which is not possible. So that means there can be only one right triangle, one right angle. So such and then if the triangle has one right angle, we call it a right triangle. And then the next type is we have one angle which is more than 90 degree. So angle which is more than 90 degrees is called an obtuse angle. So that means if a triangle has obtuse angle, we call it an obtuse triangle. So those are the three types we have. Um, so there's a naming convention. So what's the naming convention? We're going to use um, the letters ABC to represent the angle itself. So we are not going to say, if you want to say the angle at A, we are not going to say CAB. I mean, you can, but it is much easier. You represent the angle by the vertex itself. So we have ABC, three vertex, and then we use letters A, B, C to represent the, like we use letter A to represent angle A, and then we use letter B to represent angle B, angle at B, and then we use letter C to represent the angle at C. And then these angles have like this triangle has some side length. For example, the opposite to A, we have the side BC. So since it is opposite to A, it will be easier if you use something similar to A to represent the length BC, because that's the corresponding side. So that means we can use the lowercase a to represent the length of the side. So this is the length of this side. So we call it simply A. And similarly, opposite to B, so this side is this B means the length of AC. The length of AC we represent as lowercase b. And then length of AB, which is opposite to C, we represent this as uppercase, lowercase c. So lowercase letters for the length of the three sides, and uppercase letters for the angles of those three sides. So this is the this side, the length of this side, and then this is the length of AC, and like that. Okay, that's the naming convention. So opposite to the angle, there's the 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 side length of the triangle. Good. In this, we're going to focus mainly on solving right triangles. That means an triangle with like one angle of 90 degree. So again, solving a triangle means finding unknown sides and angles. So let's look at a typical right triangle. In this triangle, so we can use, so let's say this is the vertex A, vertex B, and vertex C. And opposite to A, we have the length A, and the length B, and length C. So that's kind of common naming we're going to use here. And then also we have an angle here, so I'm going to call this angle at A, you can say theta or just use A. Okay, so we sometimes use both for the clarity. And also we're going to use degrees in applications. So most applications we can use degrees. So we use degree measure. We use degrees in most of the applications in this. And also you have to be careful, make sure that you use the degree mode in the calculator. because you have to use the calculator for most of the problems here. So uh, use the degree mode. So use the degree mode in the calculator, because so what happens sometimes, like you should make like they forgot to change from radian to degrees and then do all the calculation, and then most of the answers are wrong because we did not pick the right mode. So you have to be careful with that. So degree mode. Okay, so let's try to write some of the things that we already know, because if we know the right triangle, then we can write those 6 ratios. So we're going to use the standard SOHCAHTOA argument. So its sine is opposite over hypotenuse, and the cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we can use those three to write the ratios here. So for example, in this case, you can say sine, I'm going to use the theta because we mark it, or you can just say A. So let's say sine theta, so which is opposite over hypotenuse. So in this case, you're going to get opposite is A over C. And then we have cosine theta, so which is adjacent over hypotenuse. So it is adjacent over hypotenuse, so which is B over C, and the tan theta, so which is opposite over adjacent. Good. And then also when you take the reciprocal of these, so you're going to get the cosecant theta is upside down, so hypotenuse over opposite. So that means C over A, and then the secant theta, which is the reciprocal of cosine, so which is C over B, and then the cotangent, which is the reciprocal of tan, so which is B over A. So we hardly use the secant, cosecant, secant, and cotangent. We like mostly we're gonna focus on the first three. Um, so we mostly use these three for applications. Good. Um, and then there's like an result. So we're gonna call this as a theorem. So what's the theorem is, the first one is the Pythagorean identity. So that means we know that the a squared plus b squared equals c squared. So that is one major result that we can use here. So we can use the Pythagorean identity. That means if you know two sides, any two sides, you can find the other side using the Pythagorean identity. So you only need to know two sides. Then we can use the Pythagorean identity, which is a squared plus b squared equals c squared. C means always the angle opposite to the 90 degree. So that's what you have to remember. So small c is always the side. Small c is always a side opposite to the 90 degree. And also we have one more result. Because since the angle C is 90 degree, the sum of the other two has to be 90 degree as well. So that's one other major result that we can use in calculations. So we can say that A plus B is 90 degree. So that's the other result. So that means if you know one of the angles, we can easily find the other angle. Okay, so let's look at some applications now. As the first example, we can look at this problem. So what it says that if the side length is B equal 2 and the angle A equal 40 degrees, find the other two sides AC and the angle B. So let's draw a triangle and represent the information that we have. So we can use the same naming convention. So I'm going to call A like here, and then B and C just to get used to. So we can switch, but we normally use C for the angle at 90 degree. And then so what we have is we're gonna have B equal to, that's given, and then we're gonna say this is the side A and the side C, so length of those three sides. And then we also know that this angle is 40 degree. So the easiest one to find is the other angle. So since we know that, since A plus B is 90 degree, and we can see that B is 90 minus A. For A, we don't put the degree sign name because A is a variable. So variable carries the unit. So so it's 90 minus A means 40. So if you subtract, you're going to get 50. So the angle B is 50. That's the easiest one to find. And then what we can do is we're gonna relate one of those trigonometric ratio with the information given. For example, let's say we want to find a and we want to find a. And then if you want to find a, you can see that you can relate this a with the non-b because we know the value of b. So, and then what we're gonna do, we're gonna think of what kind of ratios relate those two. That's how we know. So you kind of uh, relate two sides, one known and one unknown, with the angle. So that means if you look at those two with angle 40, you can see that the tan would be the best option in this case because we know 40. So if you think of tan 40, which is opposite means A, adjacent means B. Since we know B, only unknown would be A. So that means so we can use tan in this case. That's how we do. So what are you gonna do? We can relate unknown with the known one through a ratio. And you can see that it won't be good to go with sine in this case because if you try to write sine 40, a and c, we don't know both a and c. That means if you try to use sine 40, it's not going to help you because you have two unknown. So that means we have to relate one unknown with one known through one of the ratios. So we're gonna go with, so let's say since tan 40, so you can see tan 40 is opposite means a, and then adjacent in this case is b, but b equal 2. So that means what we can do is we just simply we can cross multiply, simply cross multiply. Once you cross multiply, you get the value of a. So that means this says that a equal to tan 40. And then what we can do, we can use a calculator and get the approximate value. And if you use a calculator, and you can see that up to 2 decimal places, you're going to get 1.68 as the length of B. Now, again, we're gonna find C. Again, we're gonna relate C with a known one. So in this case, you can see that if you relate with C and B, that's gonna be the cosine 40. So because if you relate, because the B means the adjacent to 40 degree. So so then we can write so we can say now we can write cosine 40, which is in this case b means 2 over c, and then this says that now what we can do, we can use we can use the cross multiplication again across the diagonal. So you can see that this means, so you're going to multiply by c and divide by cosine 40. So you're going to see that c equal uh, so 2 over cosine 40. So you can move across the diagonal. So how you get it? You first multiply by c the whole equation and then divide the whole equation by cosine 40. So you do those two things and then you're going to get this. And again, if you use a calculator, you can get the approximate value. So you can see that this is roughly 2.61 up to 2 decimal places. So that's how you're going to solve the problem. And you can see that it's not difficult. So what you're going to think is you're going to relate a unknown with the known using one of those ratios. You can use any ratio you like. There are 6 ratios. Normally, like sine, cosine, tan would be enough to solve most of those problems. So only thing that you have to remember is you're going to relate a known with the unknown through an angle. Okay, let's look at the next problem. As the next problem, we can look at this one. So it says solve the triangle. So you have a triangle is given, and then also the angle at A is given, which is 23.7, and also the hypotenuse is given. So what you need to find is you need to find the angle opposite to B, that is lowercase b, and side opposite to A, that is lowercase a. And then also we need to find the angle at B. So the easiest one would be to find the angle again. So we're gonna say since A plus B equal 90 degree as before, so B would be 90 degree minus A. That means 90 minus A means 23.7 degrees. So if you subtract, you're gonna get 66.3 degrees. So that's the angle B. Since the B is the exact value, for future calculation you can even use b, but if you get an approximate value you have to be careful because the error gonna propagate, so then you get more and more errors if you try to use the newly calculated values unless you have enough decimal places. So that's something you have to be careful. See whether you can always use some original values. If you can, then it's gonna have less errors. So and then again now to find b or a, you can use one of those ratios. So what I'm going to do, I'm going to use sine to find a. Now if we write the sine, we can write the sine. So let's say sine 23.7. If you write that, the opposite to the sine is a, and we know the hypotenuse in this case, so 13.4. So you can see what we do, we relate a unknown with a known, and then from this one simply by cross multiplying you can see that a is simply 13.4 times sine 23.7. Now what we can do, use a calculator and you can get the approximate value of that. So it's going to be 5.39 up to 2 decimal places. So that's how you find a. So we already know all three angles and we know a, so we can find b. To find b we can go with the cosine. So write in the cosine, so say cosine 23.7, which is b over the hypotenuse, which is 13.4, and then as before b is simply the cross multiplication, so it's 13.4 cosine 23.7, and then if you use a calculator you can see that is roughly 12.27, 12.27, and you can see that if you verify, if you get the a squared plus b squared, you can see that's very close to c squared, so there's not much error in this case. Okay, that's how we solve a problem like that. So in the so we can see that in the first problem you were given a angle and one side length, and in question number 2 we given an angle and the hypotenuse. So let's look at an angle, let's look at another problem which doesn't have any angles, only two sides. Let's see how we solve a problem like that now. So solve the triangle where the you can see that only the hypotenuse and one side is given. So the hypotenuse and one side is given. There are no angles given here. So the first thing what we're going to do is we're going to find the unknown side first, so which is b. For that we can use the Pythagorean identity. By the Pythagorean identity, so we can write as the b squared plus 3 squared equal 5 squared. So this gonna says that b squared is 25 squared minus 9, actually 25 minus 9, 25 minus 9, which is 16. Since b is positive, so you can see that b is 4. So we get the value of b which is equal to 4. So now we find all four sides. Now what we can do is we can use any of those ratios to find the angle. So we only need to find one angle because we know that using one angle we can find the other angle, because we know the sum of a and b is 90. So we can say use one of the ratios, one of the trigonometric ratios to find either a or b. Find a or a b. So let's go with b. So you can see that tan b is equals to b over a, the opposite over adjacent, which is 4 over 3, And then what we can do is B is simply, if you take the inverse of both sides, it is tan inverse 4/3. And if you use a calculator and get up to 2 decimal places, you're going to get 53.13 degrees. And then we know that the sum of the two is 90. And then you can see since A plus B is 90 degree, and then we can see that A is 90 minus B, so which is 90 minus 20, 90 minus 53. 53.13, which is equals to 36.87. So that's the angle. So we find all three sides and all three angles. So let's look at a practical problem now, like how to use trigonometry in practical situations, like finding a height of a tree, or finding a width of a river, or maybe you're finding a height of a mountain and things like that. So before we look at some practical applications, we need to look at some of the terminologies that we use. So there's one called the angle of elevation. So what's the angle of elevation? You're gonna look at an object which is above your eyesight. So when you look at above your eyesight, so what you can do, you can measure the angle from the horizontal line. So it is like you draw the horizontal line and you see how much above the horizontal line. So that angle is what we call the angle of elevation. Sometimes we call theta E. So it's angle of elevation. So you can look at an object above the horizontal line. So that's called angle of elevation. So the next type is what we call the angle of depression. So what's the angle of depression? Now what are you going to do? You're going to look below. Like let's say you are in a lighthouse, you're going to see something on the sea, so like you have to look down. So in this case we call this the angle of depression. But in practice, I mean in theoretically they are just the same thing. It's just an angle from the horizontal line, so it doesn't really matter whether above or below, because it's just an angle. But there are some names that we use. So so angle of depression is you see below the horizontal line, is called angle of depression. We call it theta d. So now let's look at a problem. So let's say so this is one of the interesting applications that we use trigonometry in practical situations. So finding the height of a cloud. So let's say you have clouds and you want to know how high it is. So what we normally do is so we go below the cloud and project a like a, let's say, flash to the cloud. Once you do that, then it's going to create a kind of spot. And then what you're going to do, you go a little away from the projector. Like in this case, you go 300 feet away from the projector, and then you find the angle of elevation to that spot. Once you find the angle of elevation to the spot, since you know how far you are away from the projector, you have a nice triangle here. We can use that triangle to find the height of the cloud. So let's draw this situation. So again, what it says that the meteorologist find the height of a cloud by projecting a vertical light beam on it and measuring the angle of elevation, which is 73.3 at a distance of 300 feet from the projector. So you go from the projector and see what's the angle and find the height of the cloud. So let's draw the situation. So we have the clouds, and then we have the flash down here, uh, and then the detector. So you're gonna detect it. So you can see that so the angle here, it's given that the theta is 20 no, 73.7, and then also we know the distance. So distance is 300 feet from the flashlight, and then you can see this is going to create a really nice triangle. So what you're trying to do is we're going to find this height h. So that's the goal. And you can see we can relate this unknown with the known using the tangent. Because if you think of h and 300, that's the tangent, because this is 90 degree, so it is tangent. So we can write the tangent here. So you can see that so tan 73.7 equals the opposite. that means h in this case, over the adjacent, which is 300. And then you can see just by cross multiplying, you can see h is simply 300 times 10, 73.7. And if you use a calculator, you can approximate this value to be, you're gonna get 1026 feet, round to a foot. Good. So that's how you do it, and you can see the calculation is very simple. So what you do, you draw a situation, and that's gonna help you to solve a problem like that. So let's look at the next problem. So what we try to do in this problem is we're gonna find the width of a river. So let's draw the situation. Let's say there's a river. Um, so that's the river. So the goal is to find this width. So we want to find what is the width of the river at a certain point. And this is like even like a bending, it's not like a straight one. So what we can do, we're gonna find some objects on the other side closest to the bank. So let's say there are some trees. So the goal is to create a triangle with a known value. So what we normally do is we're gonna so let's draw this. So what we do, we can find a we need to create like a right triangle. So that's the whole point. So what we do, we're gonna measure, like we're gonna go like 90 degree to the base, and then we're gonna measure angle from here. So that's what we're trying to do. We're gonna measure the angle from here to a some object on the other side which is very close to the bank. So in this case you can see, so we're gonna probably pick the tree. So that's the one we kind of detect. So we're gonna detect that, and we're gonna find the angle here. So let's say I'm gonna call this angle theta. This we can measure from a detector, and also you know, we can say this distance. So you can go some non-distance. Let's say you went 200 meters. So you go 200 meters from the corner, and then you go 90 degree. So first, so that's, we have the d, the width. So you go 90 degree, 200 meters, and then measure the angle to the to a tree which is very close to the bank, or some other pointers. And then from that you can see there's a nice triangle. From this triangle we can find the width of the river. So let's say you get theta equal 18.3. That's just a number. Um, and then if you call this is C, and if this is B, and if this is A, now we can just write the tan theta in this case. So you can see if you write tan theta, so tan theta is D over A. So if you plug in the values, you can see this is tan 18.3. D is the width that we need to find. A is 200 meters. And then again, if you use the cross multiplication, you can see D is 200 times 10, 18, 10, 18.3. So if you use a calculator, you can get roughly, it is 66.14 meters width. So that's the width of the river. So it's like this is how we use these things in practical applications. So let's look at another problem. So in the next problem, what we try to do, we're gonna like lean a ladder to a wall, and then what we're trying to do, we're gonna find is, we know the length of the ladder. So this is a different type of problem because we know the length now, we know the hypotenuse now. Because last time what happened, we did not know the hypotenuse, we know one of the other sides. But this time we know the hypotenuse, and then how to find the rise. So how far, like if you lean a ladder to the wall, how far it's gonna rise in the wall. So that's the kind of situation. So let's draw the situation. So you lean the ladder to the wall, and then you can see this is gonna create a right triangle. So we can call A, and then C and B, and you can measure this angle. So let's say this angle theta, which is 71.5. So you measure, and that's what you get. But in this case, we know one information. We know C. So C is 15 feet, because we know that that's the length of the ladder. We can find that. So the goal is to find what is the height it's gonna reach. And then we use the triangle ABC to find this, and then you can see we can write any ratio in this case. but we so since we are looking for the height, and since we know the hypotenuse, the best thing would be the writing the sine. So we can write the sine here, and if you write tan, it's useless because we don't know both sides. So we can write sine. So if you write sine, so you can see sine the angle 71.5 is opposite, which is h over c, so which is h over 15, and then you can see h is simply cross multiplication, so it is 15 times sine 71.5, and again if you use a calculator and approximate it to one decimal place, so you're going to get roughly 14.2 feet above the ground. So that's how much high it can go if this we have this angle. Okay, so let's look at the next problem. Next problem is like again a different type of problem. We can find the angle of elevation. So we're going to look at a very interesting example. So what we have is the eyes of a basketball player are 6 feet above the floor. So we assume the height is 6 feet to the eyes. The player is at the free throw line, which is 15 feet from the center of the basket rim. And the question is, what is the angle of elevation from the player's eye to the center of the rim? And then one more information is given. These are like all standard. The rim is about 10 feet above the floor. So let's draw the situation. So we have the basket and then the player, and the height of the player, the actual height from the ground to the eye is 6 feet. So this is 6 feet from the height from the floor to the eye. And also we have one more information. We know that the to the height for the basket from the ground is 10. So this is 10. Now we can use this information to draw a triangle, and you can see what we need is it's the center of the basket. That means we're going to draw a line from the center and then to the eye level, because we are looking for the angle of elevation to the eye. And then so this is the one we are looking for. Good. So the angle we are looking for is theta. So this theta we are looking for, it's angle of elevation, and we also know that this is 90 degree. So you can see what information we have, and we know that this is 15 feet because it's given, 15 feet is given. And also we need to know what is the distance between the rim to the horizontal line, and you can see this is simply so we can see that A is simply 10 minus 6, so that means 4 feet. And then you can use the triangle to find the angle now. So what we can do, we can write tan theta. So if you write tan theta, so you can see that this is A over 15, but A is 4 over 15. So that means theta is simply the tan inverse or the arctan. So tan inverse 4 over 15. And if you use a calculator, you can find the rough approximate value of this one, which is 14.9 degrees. So that is the angle of elevation from the player to the basket. Okay, so let's look at the last problem of this type. So this is also a very interesting problem, and this is one of the applications they use in early days to find the height of a mountain. So the question with this one is, you can see that you cannot make a hole from the top to the bottom through the mountain to find the height, because we cannot go there. So that means we have to use some other techniques to solve a problem like that. So let's know the situation first. So there's a mountain. So what we're going to do, we have to find the height of this one. So the goal is to find this h. Find h or the height. So what we can do, since we cannot go there and find the because normally, like if it's a wall, we can go to the point A here, and then we can go, but we can measure the distance from there. But since we cannot do that, what we can do, we're gonna stay away from the let's say we're gonna go like start at a point like let's say here, and then we're gonna measure this angle first. So we can measure this angle, and then what we're going to do to the top, and then what we're going to do, we're going to away from this like some distance. In this case, like, we go 500 meters. So you're going to go 500 meters, and then we're going to measure the angle again. That's how we do. Now we can see that just knowing these three information, and we can find the height of the mountain. So let's see how the calculation works. So I'm going to call these angles, so the theta 1 and theta 2. So let's call this angle is theta 1, which is 49, and then theta 2, which is small, which is theta 2. And then we also know the distance between the two, so this is 500. Whatever the unit, it doesn't matter, and then finally you get the same unit when you solve the problem. Okay, so I'm going to call, actually I'm going to use different letters. I'm going to call this is A, and this is B, and then this is C, because we normally use, and this is 90 degree, for 90 degree, and then this is D. So those are the information we have. Now we can write two triangles for this problem. So first one, we can write a triangle for the small one. So from, you can say from the triangle BCD, we can write a tan. So we can say tan 49 equals opposite over adjacent. I'm going to call this adjacent like A for this. Just call it A. So this distance. So this is A. This is the B point. So it's A, H over A. And then, so we have this equation. And then from this one, you can say by cross multiplying H equal A tan 49. I'm going to call this equation number 1. And then use the big triangle. So if you use the big one, so you can say from the triangle ABC, we can do a similar calculation again. So we can say tan 32, that's the angle theta 2, which is again H over, you can see the total distance is A plus 500. And then again by cross multiplying, you can write this one as H. So this is gonna give you H equal A plus 500 times tan 32. So and then you can see that there are two equations and two unknown. So the two unknown are H and A, and then we have two equations, so that we can solve this to find H. So you can do this in several different ways. So I'm going to discuss one method. So the first one method I'm going to do is we're going to equate these two equations because both represent the height H, and then we can find A from this one. And once you find A, you can use equation number 1 and plug in that A value to this and find the H value. So let's do that. So equating 1 and 2, so we can say A tan 49 equal 500 plus A tan 32. So and then you can distribute this one. So when you distribute, you're gonna get 500 tan 32 plus A tan 32. Now what we're gonna do, I'm gonna move all the terms with A to one side. So that means you can write this one as A tan 49 minus tan 32, which is equals to 500 tan 32, and then we can solve for A. So A is simply 500 tan 32 divided by tan 49 minus tan 32, and then we're going to plug in that in. So by 1 we have H equal A tan 32 8 and 49. So that means plug in this value, you're gonna get, and then using a calculator, we're gonna get the value 683.9 meters.